Battery. We use a battery almost every day. But do you really understand the physics behind the battery? Well, this question sounds a little bit insulting. So what are you talking about? Do you treat me as a kid? No, I'm serious.
We have often talked about power supplies, which are devices which maintain a constant potential difference.
That is a very good definition about the power supply or battery. Remember, to maintain the potential difference across the load.
This direction, this direction.
So far, so good. The current goes from the positive electrode while the resistor returns to the negative electrode of battery. What's next?
So in the power supply, the current flows in this direction.
Oh yes, that is exactly what I mentioned in my one of my short videos recently.
The electric field always runs from plus to minus potential.
Yes.
So right here in this resistor, the electric field is in this direction, from plus to minus. But inside the supply,
yes,
it must also go from plus to minus.
How?
And so inside the supply, the electric field is in the direction that opposes the current.
First of all, he assumes there's internal current running from the negative side to the positive side. However, he also noticed that the electrical field is actually against this internal current he defined.
So some kind of a pump mechanism.
Aha, pump mechanism. If you go to my video, you will see that it is wrong to use the water pump as an analog for the DC battery. It's not a water pump. The fluid is not continuous in the battery.
Inside the supply against the electric field.
Oh.
A boulder does not all by itself move up a hill.
True. So how much energy would be spent to bring this current from negative to the positive, while in the meantime, you have to keep the electron load working? Do you have to double your capacity of this chemical battery?
You remember with the Van de Graaff, we were spraying charge onto a belt, and then we rotated the belt, and the belt forces the charge into the dome. It had to overcome the repelling force of the dome. So work had to be done.
Now this is different, okay? Van de Graaff static field is built by just separate the positive and negative side physically. But in this case, the battery you are discussing is actually a chemical, galvanic cell. You cannot compare with these two devices.
In the case of common batteries, the ones that you buy in the store, it is chemical energy that provides the energy.
True, it is chemical energy stored in the battery. Now, if you want to spend that much of energy to force the current to go from negative to the positive, how much chemical energy has left? Professor? Hello?
A current is flowing in this direction through the resistor, from the plus side of the battery to the minus side. That means SO4 minus ions, which are now the current carrier inside this battery, is going from the right. They're going from the right.
No, that is the result. It's causality here. The reason they got iron left because the copper was reduced to copper atom.
Now, why would SO4 minus ions travel through an electric field that opposes them, that opposes their motion? And they do that because in doing so, they engage in a chemical.
Look, when he talk about this simple principle of the galvanic battery, he constantly looking at his notebook. It would appear that he had no in-depth study of this galvanic battery before he delivered this lecture this time.
Which yields more energy than it cost to climb the electric hill. liquid there remains neutral, and that means that some of the zinc is being dissolved.
The zinc atom has become ion, while its two electrons were taken away by the copper to form the current through the electric load. That is the point. Electron run away and zinc ion formed. The blue curve is theoretically calculated, which is to be explained soon. As you can see, the coordinates of the three planets, namely Mars, Earth, and Venus, can be quantitatively predicted. Is that beautiful? I remember my teacher said Newton was merely puzzled by the first push because he believed that his mechanics to fix the fundamental problems of the standard model, isn't it? Let's remember C.G. Ozawa, my favorite conductor, who created Arrhenius claim chief absorbent on his paper, page 260, without any direct experimental evidence, such as this one demonstrated with this Newton's cradle. As you can see, something must have been transferred among the metal balls. But what is this something?